Good afternoon. I hope you have recovered from your lunch. We are at the Think2Think Research Group summary meeting right now. Yeah, I have to go through this thing is not working. I have to go through the usual things. The note well applies. And I hope you cover all the administrivia. We need a Jabber relay. Who can do that? Somebody who is on Jabber. Thank you. Thank you, Alison. So maybe the most important part of this slide is we tend to have repositories for every meeting. And this is the repository for the summary meeting. So this is where we put things. Of course, there are also the meeting materials, but the repository sometimes has additional information in it. So you may want to note down that we are at 2017-IETF 99. This is weird. I think there's so much 2.4 gigahertz activity. I have a slide on that later on. So what we want to do is give a quick update of where we are with the research group. Also give a quick report from the workshop we had over the weekend. And then go into two subjects that we started discussing in Chicago in two breakout groups, and where we want to see what we got achieved in the meantime. And if we have time at the end, then maybe we also can talk about future activities. No. Weird. Okay, just to remind everyone, the Think2Think Research Group is an IRTF research group, so we are not in the IETF here right now, we are in the IRTF. And what we are trying to do is look at research issues that are coming up now that we have all these wonderful IoT standards that we created. And the vision behind all that is to get an internet where low resource nodes, things, constrained nodes can communicate like any other node on the internet. Of course, they cannot do all the things that the big, powerful and power-hungry nodes are doing, but they can do their job as fully fledged citizens of the internet. And of course, within this, we are focusing on issues that have opportunities in IETF standardization. Maybe I should use my own clicker here. Anyway, so just to give an overview of what's going to happen next, we plan to meet on the weekend before the Riot and ICN cluster that is happening in Berlin this September. So we're going to have a work meeting there. looking at various activities that we are moving forward, but not one single topic here that we are focusing on. And on November 10, we are meeting in Singapore with OCF. OCF was kind enough to actually put their face-to-face meeting in co-location with the IETF, so maybe we can get even more and even closer collaboration going on with OCF. But of course, OCF was represented at the workshop this weekend, and I think we have a lot of useful and interesting discussion. We are also starting the planning for 2018. We haven't really fixed anything yet. Maybe a workshop at a security conference that is being planned by W3C Web of Things is also an opportunity for us. And it also looks like Montreal will be a good place 1 year from now to have another working meeting. But yeah, what other opportunities we find out, we will have to see. The Berlin meeting will be hosted by the Free University, and I really admire the photographer here. It looks like a really welcoming institution here. I've been there, so I know how it looks like really. But anyway, it's a pretty nice building. In particular, on the 2 days they have sunshine there, and yeah, it is nice. Okay, so the reason we have put this on this date is that a lot of people are already meeting for the Riot Summit, which will happen the next days. Riot is an operating system that is quite popular in several communities, including the research communities for IoT, and the ACM ICN will happen after that. So one thing we might want to open up as a new topic in Berlin is coexistence. We had a breakout group in Chicago that discussed coexistence, and we can probably get a few research contributions on that in Berlin. Basically, the problem is that most people who think about IoT networks right now most people who work on those think that they own the landscape, but in reality, of course, we have all these various networks, both sharing the common resource of the spectrum and sharing common infrastructure, for instance, common IP networks, on which they might want to send multicast messages and things like that. So it's just interesting to see what happens when we put all these IoT networks and those 50 billion nodes out there. Will these IoT networks be friendly to each other? So it's really like the first people who built cars, they had empty roads, essentially, to get these cars going. And now, of course, cars have seatbelts and so on. So yeah, how is the more crowded landscape going to look like? And how, in particular, can we avoid one network presenting catastrophic interference to a different network without even having intended to do so? So this is a topic for Berlin, and those people who were in Chicago and discussed this topic maybe are interested in contributing to that. Now, next item on the agenda, a quick report from the workshop. This workshop was follow-on to the IOTC IAB workshop that happened in March 2016. And we tried to get together the experts that work within standards developing organizations that standardize data formats for IoT interchange. So this was not a formal meeting between standards organizations. This was a meeting between experts who want to get something done in these standards organizations. And it was surprisingly good meeting, so it wasn't like everybody had the lawyer sitting beside them watching, that they didn't say too much and so on, which we all also have seen in meetings of this kind. The materials from this meeting are in another GitHub repository, again under github.com/T2TRG 2017-07-Rishi. We had a basic common understanding after the IRC workshop last year, but we had not really a good idea how we would turn this into a working collaboration. And this meeting, the underlying theme of this meeting was to look closer at what are the areas where it's worth collaborating on and how might we actually get this collaboration going. It still was mostly technical, but we did talk about ways of working. So the first thing you need to do in this space, because there are so many organizations that do something that is of interest, of impact in this area, you need to understand what these organizations actually do. And they are all different. They all are covering different parts of the landscape. They are, of course, also overlapping. But it's also interesting to see that a group that in their marketing materials, of course, is the group that does everything IoT, in reality has a certain focus and is very, very much interested in working with other organizations that have a different focus, and so they can be a mutual contribution. So we actually started collecting these safe descriptions. You can find a first snapshot of that on the wiki that comes with the workshop repository. And of course, you also can fix that because it's a wiki. So a second thing we decided we wanted to do, but we didn't get very far with in the 1.5 days, was collecting a corpus of use cases and examples. Now, interestingly, many organizations have such corpora, but to actually pull this together and structure it and so on, you need to solve licensing problems. So that actually is something that we also discussed. We have started putting together a glossary of relevant terms and want to put together references to relevant tools. Of course, this is an environment in which tools play a big role, and anything that is available for facilitating the work that is needed here is helpful. And another thing that the research community often is neglecting a little bit is we really want to collect things that didn't work so well, and maybe also why they didn't work so well, so we can avoid falling into the same trap again. Yeah, I talked about licensing. We need to understand licensing terms and the impact on collaboration. And in particular for data models, which essentially need to be merged to get an overview of what's going on in one IoT environment. Those those models usually have license terms which are a little bit opaque and hard to find out. So maybe one result here could simply be a machine-readable tagging of those license terms. Now, there are tagging schemes for license terms that are used in other environments, and we have to find out which are the properties of such a tagging scheme that we actually want. One other thing that also is important here is not everything has to be done by everybody. So there's a lot of productive bi- and trilateral collaboration going on, and it would be useful to know what is going on and how this is being done, so other organizations that are interested in contributing there can find that out and can do that. Um, yeah, there are a few technical goals that maybe are a bit more work than just collecting things. One aspect that came up repeatedly is that applications often are interested in the composition of various information resources available that is not exactly what has been defined by standards so far. So I have this environment sensor over there, and I really only need the humidity and the temperature, but I'm not so interested in the CO2 level right now. How do I get this information in a way that is reasonably efficient? And yeah, you want to define these compositions, and then of course you want to have the protocols for fetching and observing those compositions or service objects or however you call them. So this is something that is underdeveloped in the current documents. We also found that things that are called metadata often only get second-class treatment. Well, that starts with the term. We had approximately twice as many definitions of metadata than we had participants. We need to define what metadata actually means, or what kinds of metadata are of interest here, and find good ways to express and deliver those metadata. And it's interesting that many metadata actually are contextual, so they are not necessarily created or maintained at the same place where the data for those metadata are created or maintained. So we also have to find ways to plug this all together. Yeah, and there's lots of other things we can do to facilitate the interoperation. And one of those is, for instance, just doing experiments in model translation and in translation of data between different models. These are two different kinds of translation. Now, how do we get there? Well, first of all, as with every such workshop, you build a little bit of common infrastructure. We have that GitHub repo, we have wikis, we probably will define further wiki pages and repositories, but we will also collect other tools. For instance, OneIOTA is a tool for collecting models, and while this is a tool that is closely associated with OCF, one of the participating organizations, it actually has a wider scope, and we want to exercise using that tool to find out how well that works. And we may want to have other tools, and one thing that repeatedly came up was registries for identifiers. Of course, there is IANA, but there is also Omna, and every organization has their own registry, and sometimes those are too heavyweight. So are there maybe more lightweight registries for identifiers that can be used? To make this happen, we will have monthly phone conferences. So the next one will be end of August. And of course, the objective is to get two common plug fests that are about plugging things together that conform to the various specifications in play here. Now, to talk a little bit about the technical content of the discussion, it seems that there is something like a 3-layer model that everybody uses in one or another variation. And one item of work will be to define this model in a little bit more, with a little bit more precision than we have at the moment. So there is something that can be called semantic interoperability, which means we understand what the data mean. So when you have a mass probe and give it some trajectory data. You understand that it's in foot and not in meter or something like that. That's a simple example of semantic interoperability. We have structural interoperability, where we have data that is complex, that is built together in different ways, and where the various parts of the system understand the structure of the data, or also the structure of any actions done. And third, we have the syntactic interoperability. So we actually can interchange these things. We cannot only understand them on a theoretical level. Now, as with most layered architectures, in reality, we have recursion. So for instance, if you look into the structural interoperability layer, you actually find that, there are structures that are more on the semantic level, which you typically call information models. There are data models, which are really about structure. And then there are something like generic data models or serialization frameworks, which reach down into the syntactical level. So we may have a little bit of nesting here, which is always a little bit difficult to understand, but it helps in getting this model actually be useful. Yeah, so this is terminology work. This is not the only set of terms that we came up with, but I wanted to focus on one specific here. There's also a number of areas where we are just trying to understand the diversity of the requirements. So for instance, when we are modeling data, we are not only modeling the data themselves, we also have data that are needed for security purposes. And there are the obvious ones, for instance, what data do you need to actually get on the network and so on. So lots of stuff is happening there. That's maybe not the area where we have to focus on. Yeah, there is management of trust relationships, where it's not always clear whether people who talk about trust relationships in reality are talking about authorization and not about trust. The term trust is probably one of the worst terms we have in this space. But relatively unexplored are the other four areas. This is from a list from Dave Taylor. We probably will add more precision to this, but this is the state of Sunday 4 p.m. So we need metadata about security of data. There are authorization requirements. Only certain people can read certain data, only certain people can write certain data. But how exactly do these metadata look in an IoT system? It took the IETF about 4 attempts to define security metadata for network management. So those who have followed the development of SNMP probably will remember that. This is not easy, and it's very easy to do process configuration here, which means you build your metadata to an ideal version of what should happen. But of course, in reality, things do happen in a slightly different way. So this is an important area. And then the next point here is, of course, if we have all these metadata flying around, how do we maintain privacy? So because these metadata may contain more information than you actually want to divulge. So maintaining privacy, in particular within discovery processes, is a problem. And of course, there are also related problems like finger printing. So even if you think you have all the privacy, you have done all the privacy, the metadata may still reveal too much. Like with browsers, which fonts you have installed tells you a lot about who you are. Yeah, the metadata about privacy, of course, is a special case. And it's probably important to look into the changing legal framework here as well. So in Europe, we are all watching the remaining months until the general direction on privacy regulations, whatever, are becoming the law of the land. And things are changing very quickly here. And finally, there is one area in which I think the IETF already has done some work, but more work is needed, which is the privacy of identifiers. So we still have these MAC addresses that are often used and that are in beacons and so on, which tell you a lot about who is in the building and things like that. And one particular thing we are interested in is getting progress on an area that we are calling secret handshake protocol. So the idea here is that you, for instance, can have a coffee mug, that you carry to a coffee machine, and the coffee mug and the coffee machine find out whether the coffee machine is authorized to give you coffee. Now this sounds relatively easy, but when you add the requirement that the mug should not really divulge who you are, and the coffee machine doesn't really want to divulge all the contracts that are there in the background about giving out free coffee, then it becomes interesting, because you need mutual authentication without either side giving away who they are, except to people who actually can authenticate and are authorized to get that information. So this actually requires some crypto primitives that we don't have workable standards for right now. And this is also an active area of research. After the workshop, Dave Taylor dug out a few papers about that. These are slides from Dave. So there was a seminal paper in 2003 that essentially defined the problem, of course, framed in terms of CIA agents, but even non-CIA agents occasionally privacy. So you want two sides of a communication to authenticate to each other without giving away who they are. And these people already started defining this as a TLS cipher suite, so they were thinking about implementing it. And other people have then later come along. And we think this is a requirement that is very important for the Internet of Things, because we have all these unplanned rendezvous between devices and people and devices and devices, where it just would be nice if a device could find out whether it's supposed to talk with somebody else or not. We imagine that there are actually other areas that could make use of this as well. And for instance, one of the areas where we also have found the need to do this is in DTLS session resumption, where it also would be useful to be able to initiate a session resumption without already giving away who you are. Okay, so the research is ongoing. It's not exactly happening at a high-powered rate, and we might want to help accelerating that a bit. So this is a pretty spotty summary of the workshop. Of course, it's hard in a little couple of minutes to summarize a two-day workshop, but you can find the materials online, and I hope we will actually be able to write out more of the things that happened in the room. There's also a 30-page minutes document, so if you want to know all the details, you can find that. Any questions about that?
And also, since many of you were there in the workshop, so if you have any reflections, because this was a set of issues that our chairs wanted to highlight from the workshop, but as Carsten said, it was a two-day workshop with a lot of topics, so if you, the ones who are participating, have any issues you would like to highlight from there, we can take them now or maybe at the end of the session, either way.
Okay, in that case, let's go to the agenda. We're ahead of schedule. So Dirk is going to say something about the work since Chicago and edge computing.
Try.
That's not working very well. Yeah, exactly. Start talking when you get the start.
Okay. All right. So this is essentially summarizing our little breakout discussion on edge computing in IoT that we had in Chicago. So who of you was actually in that breakout discussion? Can you? Okay. Thanks. So this is basically the result of your work. So Yves Schuler and I put this together. There is a kind of report that was in the meeting minutes from last time. And so this presentation is summarizing this and pointing to some additional ideas, activities that happened in the meantime. In this presentation and also in that report, you will see many, say, questions. I hope they are interesting. You won't find that many answers, to be honest. But I think it was actually quite a productive discussion, and so I think, led to some like interesting or potentially interesting activities that we thought this group could be looking at. How are we doing with the slides?
Well, the slide looked great. It was just a blank piece of paper, and I'm trying to find out why.
Okay. That looks good. All right, so next slide, please. And yeah, so there's a little structure that we made up ad hoc at the meeting. So I was trying to understand a little bit what do we actually mean when we say IoT edge computing, so like terminology. Right, so firstly, questions: why would you actually, do edge computing in IoT? So what is it? Why are people thinking about this? And so what we said is, okay, I mean, there are like certain set of motivations. So sometimes like access to data is delay sensitive. So you want to have some like network locality. There's often, so in like an industrial IoT, for example, you generate lots of data, and so there's a high volume, and you need to kind of pre-process it before giving it to somewhere else. These days, I mean, many applications are, developed in a cloud-centric approach. Sometimes you actually don't want this. There are like trust sensitivity issues. Some IoT networks are intermittently connected, like vehicular networks, for example. Sometimes there are like energy conservation constraints or just cost constraints in transmitting continuously large amounts of data to some like centralized processing unit. Is the clicker working, or?
You can try it. Should be, but
could be easier. Next slide, please. Okay, so thinking about technology, so you could ask, I mean, what does the term edge really mean? So is it really a, say, network topology edge, so something like an access network edge? Is it maybe also something like an organizational edge? There is the admittedly slightly foggy term called fog computing. So this seems to imply like a multi-tiered edge computing approach, where you have like different, say, levels of processing, for example. So one notion that was brought up is, okay, so nowadays we have all this, established architectures, tools in data centers for big data processing, for example, or distributed application design. And so bringing these things to the edge, you could actually see this as reimagining, say, infrastructure for distributed application design. So reimagining the data center. So moving computation, but also storage, control, management out of data centers. One interesting question is, so what are actually the dynamics that we're talking about? So there are, ongoing activities, for example, things like ETSI mobile edge computing. So like an idea that you, say, install VMs on base stations, so in general. So this is a kind of coarse-grained, say, approach. So you may have other use cases in IoT where you need something a bit more fine granular. So the question is, how dynamically would you create edge compute functions or instances that execute functions? So how dynamically do you need to also adapt to different events in your local edge? So yeah, the, say, mainstream or like legacy idea of edge computing is often that, okay, you have some, IoT or car gateway that, does some pre-installed computation. Doesn't always have to be the case, right? I mean, especially like in this group, we're also trying to, investigate, say, more distributed approaches, like thing-to-thing communication. So that this may also mean that you want to be able to delegate computation not to a gateway, but maybe just to another thing. Okay, next slide, please. So a couple of questions that came up. So in the cloud, I mean, there are established ways to program distributed applications. There are kind of tools for stream processing and so on. So how would you, say, in a, say, more distributed edge environment actually develop applications so that could leverage those edge computing resources? Yeah, what would be good abstractions for that? So assuming there is some, set of tools, so for like executing certain functions, maybe storage, caching, and so on. So how do you control this from a programming, but maybe also from an operations perspective? Yeah, especially if you think about enterprise or industrial IoT, of course, you have often also well-managed networks. And so what would be the management orchestration requirements for that? So like one notion that was brought up is, so ideally it wouldn't, so the things you have to do for edge computing wouldn't differ too much from like already existing enterprise orchestration management systems. Next slide. And then, yeah, if you think about computation on, say, maybe also third-party platforms, maybe also concurrent computation processes, perhaps multi-tenancy, how would you achieve isolation? Maybe also some fairness questions could come up. Especially if you think about not only like one edge computing platform, but a, say, set of like a tiered model of different platforms that provide a larger application that is distributed. Right, so you may have heard of certain edge computing approaches. So I mentioned the ETSI mobile edge computing activity. There's stuff like, AWS Greengrass, for example, that's basically Python function execution, I would say. So what is actually the unit of a program or of a function? So is it a VM or container? Is it like a simple step function? So where do we actually keep the state that you need for maybe subsequent invocation of those functions? So in ICN, we have a certain idea. I can talk to this a bit later. Yeah, so this whole topic of you have multiple applications, multiple tenants, that yeah, was brought up as a potentially interesting topic to discuss further in this group. Next slide. Right, so I think I alluded to this in the beginning. So if you look at the existing set of tools that already exist in APIs, so is it actually possible to kind of reuse some of those and kind of just extend the number and nature of the platforms a little bit without coming up with completely new models? Yeah, so how usable would a system really be? So considering that there may be some unpredictable network disconnections or say overload, so load problems. So how can you develop distributed systems with a slightly challenging, in a sense, a challenged environment? Also in IoT in general, I mean, so if IoT gets scaled up, so I mean we are talking about billions of nodes, we won't be able to take care of each node individually so well. So moving from a pet to a cattle model, and so assuming this would also apply to distributed computing, you could imagine that security could be an interesting challenge, right? So these are could be like execution platforms that you create dynamically at a high rate. So this beta should not screw up too many things. Next slide. Right. So in the say hyperscale data center environment, there are like established architectures, set of tools, how to build highly scalable systems, so like rack scale, for example. And so you basically are able to, put resources together, automatically scale this up automatically, and so on. So it doesn't make sense to develop as like comparable set of concepts and tools for edge computing. So also what would be, say, the network control and telemetry approach. So, I mean, we have technologies like software-defined networking. At some point, you may also want to control your edge computing platforms a bit better. Yeah, from a networking perspective, so yeah, the question is, how would actually maybe also affect the way that we communicate in IoT? So you could imagine if you have like programmable systems, say somehow, for example, sitting between a thing and maybe some cloud backend. Well, you need to think about how does this edge computing or like this computing function actually get to the data. I mean, someone needs to be maybe in the security context in the path. So hopefully, I mean, you don't have to invent man-in-the-middle attacks to make this happen. So that's, for example, something that also the ICN guys are discussing. So how can you combine like secure access to named data with triggering dynamic computation so maintaining the security. Okay, let's move on. So what also happened in the meantime that could be, say, related to this discussion. So yesterday we had an IETF side meeting on a topic that we called distributed internet infrastructure. That's the idea of decentralizing infrastructure, so becoming perhaps less cloud dependent. Yeah, for IoT, so edge computing would be one of the use cases where this could be of relevance. So if you're interested, there's a wiki page that does not yet, but will soon kind of list the presentations from yesterday. So it was actually quite good discussion on these topics. So I mentioned ICN before, which yeah, could be say, interesting technology to enable edge computing or like in-network computing securely. So ICN in general is about accessing authenticated named data. And so this could be static data, but it could also be data that is dynamically created. And so there's a kind of research activity in ICN that is working on I'd say, really lightweight dynamic function invocation idea. And so there was on the next slide, you see, there was a workshop on information-centric fog computing at IETF networking in June. Next slide. That discussed a few of these topics. The papers and the presentations are available at this link. And on the next slide, I have a kind of brief overview of the program. So, so Yves did a really interesting keynote on that topic, specifically for like ICN in the wireless edge. And so, like the first block of presentations actually dealt with like enhancing or augmenting co-op with ICN concepts or ICN underlays, so a bit of like an initial deployment idea. And so in the second session, there were two papers about this named function networking idea that I mentioned earlier. So this is the idea that, say, for example, in an ICN request, you would basically specify not only the name like, of a static data item, but actually something like a function expression. And this can be evaluated by the network in different ways. So perhaps depending on the actual dynamic, say, network or resource availability. So for example, you could say, I want to apply a certain function on a larger data set. So you could say, okay, I fetch all the data items and then I run this locally on my gateway. But you could also say, okay, I actually move this expression to where the data is, and then maybe have further ways to re-evaluate this expression. So that's it's a kind of really interesting activity that's currently going on in the ICN community. Okay, let's move on. So yeah, we are thinking, so there is actually really good opportunity to rethink IoT edge computing with a slightly more decentralized approach that is less cloud dependent, enables more local functionality. And so it's not about saying, okay, actually we don't need like cloud backends anymore. It's just perhaps it's a good idea to design the systems in a way that are not cloud dependent. And so potentially this could mean that so like a lightweight functional execution approach would be useful. And so like enabling the formation of like the dynamic formation of local edge computing clouds. So even I was thinking that could actually be documented nicely in a draft. So maybe also spending a few more cycles on actually saying what the problems, say, of slightly more mainstream approaches are, and like trying to develop a few concepts for a more like thing-to-thing inspired edge computing approach. And finally, maybe provide a more solid description of the say, detailed research challenges. So yeah, we are kind of eager to put this together. If anyone wants to help with that, please speak to us, and we're happy to work with you. So that would be the summary of the discussion so far. I'm sure I missed something. Let me know if you have anything urgent to add.
So just to make sure that everybody stretches after the lunch, who has heard about edge computing? So who thinks that the IoT actually is a place where we will use this kind of functionality a lot? Okay, so we seem to agree on that. And who actually thinks they will be contributing to this field over time? Well, that's quite a few. So Dirk, maybe just remember the people who just raised their hand. So final question, who actually wants to help Dirk?
Good. That's a good number. Okay,
Great.
Thank you.
Thank you. Lloyd? Just everything I just did.
Karsten, there was a leftover question on the Jabber. I forwarded it to you by email about one of your discussions in the Wishy presentation. If you can take a look at your email, you can answer the question. It's about the socialist millionaires algorithm and whether you guys considered it.
Okay. I can't get at my email right now, but.
Okay, well, so I sent it to Ari too. It's a long message from one of the Jabber participants.
Okay, I can read out the question out loud. So the question is, are any of the secret handshake authentication mechanism proposals related to the socialist millionaires protocol, El Gamal? I thought that was a pretty well-established way to do that sort of secret handshake thing as used in OTR. Good question.
Yeah, I think that's. Mohit, you just probably know the answer. So. Yes. I hope it works better than the other one.
So we didn't go in particular that long in the details during the Wishy session, but we could certainly take this offline. Thanks.
Thanks for the question.
Hello everyone, I'm Mohit and I will be presenting what we discussed in Chicago and what has happened since then. So here is the outline for my talk. We will first look at what does authorizing network access for IoT devices mean, what are some problems and challenges. We will also look at one possible deployment scenario where the authorization decision is delegated to the cloud. We also look at what are the challenges in bootstrapping security between IoT device and the cloud. And I don't want you to leave just hearing about problems and challenges, so we will also look at one possible solution, which is EAP noob. So what does authorizing network access for IoT devices mean? It just basically means once I have a new IoT device, how do I authorize it to connect to my local network and to the internet? Why would these devices need to connect to the internet? Well, they would possibly use some vendor or third-party services. So I have this Wi-Fi weighing scale at home, and it keeps a log of my weight and BMI and then recommends me a diet plan. So that's one example. But even if I don't use any of these services, they would hopefully connect to the internet and receive some software and firmware updates. So a couple of other examples is this smart doorbell, which lets you see, and you can already buy these things online. So the smart doorbell lets you see who's at your door, and I have this smart plug at home which lets me control my appliances remotely. So what are the problems when I want to authorize network access for my new IoT device that I just bought? Well, first is discovery and configuration. So I bring it home. How do I tell, like, this is the access point that you should connect to, or this is the ZigBee gateway that you should connect to, and so on to reach the internet. And not only this discovery, but it also needs some kind of identifiers and credentials to connect to the local network first and then to the cloud on the internet. So how do I provision these credentials and identifiers on a device that I just bought and has no information about me as an owner. So to solve those problems, we have some challenges. Many of them are fairly well known and well understood. So of course, these devices don't come with a keyboard or a mouse with which I can go and say, this is the SSID that you should connect to, and this is the passphrase that you should use for connecting to the access point. Scalability is of course a challenge. So if my daughter's Barbie doll is connected to the network and my Wi-Fi weighing scale is connected to the network, it's no longer just one or two devices that will be at home, and as more and more devices get connected, scalability will be a big challenge. And most of the existing tools and protocols that we have, such as WPA Personal, ZigBee, and BTLE, rely on a network-wide shared secret, and that is very hard to scale once the number of devices grow. And of course, usability remains always a challenge. So we need something that not only works for you and me, who are more or less internet experts, but for naive users at home who don't necessarily understand everything. So if you look at what are the current solutions for network access authorization, they can be broadly categorized into two. So there's a manual configuration, which basically means I somehow manage to tell this new IoT device for example, Wi-Fi SSID and password, and this might be through first pairing it over Bluetooth, through NFC, or what some would call Wi-Fi unprotected setup, where I press two buttons at the same time. The other category is the managed solutions, which uses 802.1x port-based authentication, and this basically requires you to have a back-end AAA server and then have certificates installed on all your devices. So this is something that we discussed in Chicago, was a possible alternative deployment model. So where we delegate the network access authorization decisions to a remote cloud-based service. So to give you an example, think that you just have bought a new IoT toothbrush. Wouldn't it be nice if the IoT toothbrush service could somehow tell your access point to enable internet connectivity for it? I know this looks very easy on the slide, very nice. If you have something like a Radius server and AAA and all these things running in the background, you already have these tools to do, but there are still many research problems that exist. So the first challenge is, of course, not everybody understands what Radius is and what 802.1x port-based authentication is. So we cannot expect them to configure Radius if we can't expect them to understand Radius. So that's a big challenge. Going back to the previous slide, if I delegate to this device vendor to enable internet access for the new IoT device, how do I then limit his power? So I don't want the IoT toothbrush vendor to control all my network access and all my devices in the network. So I need a way so that he can only enable network connectivity for his devices, but kind of not influence the rest of the network. And if I'm going to buy devices from multiple vendors, how does this delegation work, and how does interoperation happen between multiple delegates? Also, isolating devices is kind of necessary and also challenging. So once I have these devices, and maybe some of them have reasonable security and some others not, how do I make sure that one broken one doesn't break the whole network? There are several other remaining challenges. So how do I monitor the behavior of my device? I just bought a new TV. How do I know it's not listening to me, watching to me all the time and sending some data back to the vendor? So that's of course would be a nice feature to have, but challenging to solve in practice. And multi-homing, mobility, multi-owner devices. So I won't be the only one using the smart TV at home. There would be other users. So how does that work out? So this was a rather short introduction to the research questions and challenges, and I'm the one who causes all the problems. So I'll ask my colleague Thomas to present one possible solution.
So I wonder if there were any questions or comments for Mohit at this point. We've been working on this EAP method for out-of-band authentication, and it kind of addresses not all, but some or a few of those problems mentioned earlier. It's of course just one approach. There's an internet draft, and there's code on GitHub which has been updating very fast in the recent days. So this is an EAP method, and idea is to do out-of-band authentication. But it's a rather special EAP method, unusual in the sense that you don't have any pre-existing relation between the peer device and the authentication server, and also no authentication credentials, actually no identifiers. And the user is what kind of where you bootstrap the security. So the user assists in this out-of-band authentication, and that creates the association between the peer and the authentication server. So what would we use this for, or why did we start developing this? Well, the idea is that it's for connecting this smart appliances to cloud services. And then when you buy such an appliance, like the ones in the example, they often have no these credentials or names or identifiers or addresses where to connect to, at least if they are kind of interoperable and not completely under one vendor's control. So here is an example of the user experience that we aimed for. And so you go and buy lots of displays and start hanging them on the walls. And maybe this number of displays is such a large that you would like to make it as convenient, and display also has very limited user interface. It just has a display and possibly a power button. And so once you nail the display on the wall, you power it up, and in this case it looks for the networks around it and finds one that is our university network, and shows a QR code that is dynamically generated. The user then picks up any mobile phone with a QR code scanner, scans this QR code, and gets to a web page on a server somewhere in the cloud. And now, of course, the user needs to have an account on that server, or well, could sometimes create that on demand, but usually will have, at least after the first display, will have, or the second one will have an account there, and will log in, or maybe already is logged in on the web browser on the phone. And once the user has logged in, the display is now connected to the cloud and starts showing content that is then sent to the display or selected by the cloud service. So we've kind of got network access and also associated on the application level the display devices with a cloud service. And there was no previous password, no previous accounts, except the user had one. But so how could we do this network access and registration to the backend in the cloud in just one step? Well, what did we do? There was a single user-assisted out-of-band message that went from the QR, was scanned as a QR code, went through the phone, and then through a secure HTTPS connection to the cloud server. And that is usually not enough for, I mean, usually not possible, but of course, we use this AAA infrastructure and EAP to help us. So here is a picture of the architecture that is, there are these IoT appliances that have either input or output capability, and then they would like to connect to a wireless network, and that wireless network is now infrastructure mode network, so it's managed by a local AAA server. radios in our implementations, and then there is a trust relation between that local server and the remote radio server in the cloud, which is then the other endpoint of our protocol. And the communication channels here are the in-band communication that we actually put through the EAP tunnel. So that's how we managed to do the cloud registration at the same time, registration to the authentication server in the cloud at the same time actually before getting network connectivity. And then the security comes from this single out-of-band message, which goes either from the cloud server to the IoT appliance or the other way with the help of the user. So in this case, that is, well, kind of typically it's a smart or some kind of mobile smart device, and then HTTPS or TLS connection to the cloud server. So that kind of explains how we managed to manage this, so that how is it possible with one message to get network access and register the device? Well, I already said it, but maybe to summarize, we had so we had have the in-band communication possibility through an EAP tunnel between the peer and authentication server before the device is registered. It's just, you know, we can put anything through that tunnel, and we put what is necessary for our, in this case, in our EAP method. And then the user actually has an account already in the cloud server, or creates one, and has secure connection over from the web browser or HTTPS there, or it could be an app on the mobile device, and then a secure TLS connection. And then the access network has been configured to trust the AAA server, or in other words, the radio requests are forwarded to the remote AAA server, the same server where the user has the account. So if we look at the kind of cryptography that goes on in the background, or the messages, there is actually two EAP sessions in this process. The first, an initial, what we call initial exchange, that happens in band. It's just unauthenticated, kind of opportunistic Diffie-Hellman, elliptic curve Diffie-Hellman key exchange. And then the out-of-band message authenticates that in two ways. There is a secret sent in that out-of-band message, as well as a hash of the data. And then in the completion exchange, we authenticate the elliptic curve Diffie-Hellman using the data from the out-of-band message and do key confirmation. And that's how we have created the association between the peer and the cloud server. So the security really comes from this in-band Diffie-Hellman, and then authentication out of band. There's some details there, but I won't go into that. I will be happy afterwards to explain in detail what kind of security we get. Maybe the one thing that I should mention is that that out-of-band channel needs to either provide confidentiality or integrity of that out-of-band message, but not both. And also the out-of-band message can go in either direction. So that's kind of what has been the challenge in designing this protocol, to take into account all these possible cases, make it as generic as possible. The out-of-band channels that we have been thinking about, for example, this dynamic QR code or dynamic NFC tag, or NFC can also be used from the phone server to phone to the peer device communication. And audio cable was one example of another type of out-of-band channel. Then the association becomes persistent once it's been created, so that we don't ask the user to redo this for the same device, but rekeying then after this happens without user interaction. And who could these cloud-based service providers be? Well, organizations can set up their own AAA servers, sure, but we would maybe more likely expect there to be device vendors or the network service providers or content providers in case of displays, or some kind of third parties who just like to register stuff. And the protocol could also be used for device-to-device security bootstrapping, but it's not as optimized as the device pairing protocols for that purpose. Roaming is possible after the initial setup in the home network. If you want to do the initial setup elsewhere, the user interface becomes a bit complicated. This is maybe the kind of, for this research group, a most interesting slide here. So what did we learn from this? So well, one thing is that the security bootstrapping is actually, you could call it also device registration, or the user taking ownership of that device. Then when designing the protocol, we have to remember that there's no names or identifiers for the device, and or if there are, they can't be trusted. They could be conflicts or intentional conflicts. Is that the timer? And then probably the most important thing is we spent a lot of time working on this protocol specification is that we want to avoid rerunning the user-assisted out-of-band step at any cost, always. So you can't just, if some failure happens, you can't fall back to the unassociated mode and start from scratch and ask the user to do this again. So you know that, I guess from experience, that for your personal devices, if you have to create the security association third time or every time, like my camera ones, after 3 times I just stop doing it. And then if it's a business or industrial setting, sending a support person or engineer on site, possibly by aeroplane or just walking to another floor in the same building, that's expensive, and it doesn't scale when the number of such devices grows to maybe thousands or millions, and one fails every minute. Then also the protocol needs to recover from various malicious attacks so ones that don't compromise the security of the authentication, but actually try to put it in a state where it cannot recover. So it has to try its best to recover from anything that happens. Then, because user is part of the protocol, we have had and still had, I guess, quite big difficulties with deciding the timeouts and how often to retry, how long to retry, how to back off, because if it was just computers and just the network, we could just define this, but now it's the user that is part of it and is expecting something to happen very fast. So that's kind of one challenge, that the usability puts some conditions on the protocol and its parameters. Something I found quite interesting is the influence of this kind of ad hoc association or creating new associations on the algorithm agility. So we want to be able to support upgrade of crypto algorithms. But normally you have some kind of initial credentials that are, so let's say you have a long shared secret that you start with, and you use that for generating your session keys. And if that's what you do, then when your, let's say, your Diffie-Hellman curve needs to be replaced, you just go back to that original strong secret and use a new curve. But we can't do that because we created the original secret in the association, or the master secret was created by us with this crypto algorithm, with Diffie-Hellman in the initial association, and that makes it a little bit harder. We need to upgrade the master secrets when upgrading algorithms. And also, I guess there's the typical question people ask: well, do I have to? How can I use this at home? Because I don't have EAP there or WPA Enterprise. Well, our take on that is that everyone should have that, and the complexities for the average user can be hidden in case they want to use a shared key. You could still use the same protocol, and then it would support such extensions. Here's the final slide. So it kind of repeat some of the lessons that Mohit already mentioned. Now that we have this method of delegating to third parties, like some cloud server or device vendor, the control over access to our network, then that makes me, of course, a little bit worried, and I would like to monitor what these devices do in the network. I would like to be aware of which devices are there active, what kind of connections, what are they doing. So some kind of situational awareness, I think, is important for the network owner. And then it would be nice to isolate these. And virtual LANs, we have tried it and it works, but then there's only so many virtual LANs, and the access points currently support only so many SSIDs and virtual LANs for them, so it becomes a bit complex to isolate large number of devices with the current networks. And then anyway, we would like to limit the power of that third party to who is the AAA server, running the AAA server. And if there's multiple such parties, they need to somehow work nicely together. So those are kind of the challenges that arose from this work on EAP Noob. That's all I had. Questions? Karsten?
Not sure this is a question, but maybe it can become one. This all sounds vaguely familiar. When we set up EduRoam 15 years ago, we of course had the same problem. How do you run the interactions that are necessary to establish network access before having established network access? And we all know how this is done today with radios and so on. But we actually were looking at IP-based ways of doing that as well. And what we actually came up with was a form of this isolation you are talking about. So we achieved this isolation at the time by simply identifying a part of the IPv4 address space that was available to nodes that weren't authenticated yet, and that could be used for running the authentication mechanism. And then when everything was done, of course, one would get access to the whole network. Now, this was very crude and hard to scale and so on. I'm not recommending that that experience is repeated, but maybe the basic idea of using isolation a lot more and still using IP and not using special tunnel protocols like EAP, or here in this case, the having to actually put a user there that sends packets.
We started from that direction and high layer, but then there is the question, how can we communicate with the backend?
Yes.
Well, we could maybe use DNS or something for tunneling stuff, but yes, in the end, EAP is the standard protocol for tunneling things before you are authorized for internet access, tunneling to a specific destination.
I understand how the world looks today. I'm just wondering whether a world in which we actually could identify traffic, classify traffic as to its security posture could help us.
I think it would be nice to have some kind of limited network access for specific purposes only.
So at the time when we did this, we of course had to harden those places that were exposed to unauthenticated users. So those people who actually put systems into this controlled address space kind of designed that they were making sure these could not be easily attacked and so on.
So using the IP addresses for isolation within the local network, like let's say, can devices access each other? That is tricky because the communication actually on the access point goes through, unless the devices are on different SSID, then it goes only through the access point and not through our boxes. So we had to take an open source, OpenWRT access point and hack it so that it would send all the data to our router, which then sends it back if it goes to another wireless node. And that kind of you can't, with the current hardware, you can't have this IP layer control over the devices that are in your wireless network.
Yeah, but maybe the take-home message is that we actually have to think more about putting isolation features in our networks.
Yeah, definitely.
So we can do things like these or things like the one we did 15 years ago without having to come up with these monsters and the special implementations and so on.
Hi, my name is Andrew Sullivan. So actually, I want to pick up on that conversation a little bit, because the challenges that you listed here, it seems to me, are primarily about either the LAN or the device within the LAN, or else the device and its relationship to some sort of cloud provider and so on. But of course, there's the rest of the internet that is threatened by these devices as well. And so the same kind of isolation discussion that we just had could also be used to address that other problem. Or maybe something else could happen here. But
yeah, so we actually tried. We did the little bit that we have done about that.
Oh, okay, cool.
Was that we actually had a version that we are the firewall router on the local network tunnel isolated the device in such a way that it created a VPN tunnel for its device and tunneled it back to the cloud server. So all communication went that way. It's not optimal routing, but sometimes that might be the right solution.
Well, non-optimum routing would be just fine for the purposes of at least of the rest of the internet. But there is this new difficulty that introduces, of course, that then the vendors of these things are going to want you to have their kind of gateway, and so then you're going to have dozens of gateways.
And also, I guess a bigger kind of the immediate problem we had then is that we don't actually want, so once we do this association and network access, then we want to hand over the cloud side control to, when it's a display, we want to hand over the control to some display management service and not keep it at the AAA server.
Right. I mean, I think there's something really fetching about this line that you're taking, and I like it. But I just want to press a little bit to make sure that the importance of, it can connect to these things that it's been allowed to, and not to everybody else, because that's, that's maybe it's because of my employer, but I'm slightly nervous about that.
We are as well.
Thanks.
Eric Nordmark. So if you were to do this for your sort of house, right, you have some privacy concerns about these devices and whatever metadata that might be registered in the cloud with them. And it would be nice if this could sort of only live in my little cloudlet over there, and I control that thing. So have you thought about how you can sort of redirect it to this thing will actually end up pointing only to Eric's, repository in the cloud and not be accessible to the big giants out there that want all the data?
Well, maybe I had I see that's an issue. I guess our concern at the moment is still that we are running our own server, and we would like some big vendor to take over and implement the server side and provide that server, especially a third party that kind of, but of course, that would provide this service to any device that then implements the peer end. But I'm not sure how that.
But right now, so how do you select which server this goes to? You have to configure your home router in a DAP configuration?
And for the application level data, there certainly will be the privacy issues, but that's a kind of depends on the applications. I mean, with the displays, our main one concern is that if you hand over control of your displays to some third party, they will also start putting advertising on it as part of the deal.
Sure. Yes.
Hi, my name is Michael Richardson. I look forward to reading your O2 draft. I see you posted new information, and I hope to see what kind of responses you had, because I know you've discussed Noob and quite a number of other working groups over the couple of years. Just so the room knows, the Anima, NetConf, and 6TISH working groups got together to deal with a lot of this problem of how do we connect to IP to connect to IP. And we have a number of solutions which are approaching either working group last calls or some cases for the voucher document, which essentially authorizes the fact that you are the owner of a particular device, has passed working group last call and expect an RFC soon. So there's a lot of other work that's happening in this, and it would be interesting to see how your document could interact with some of those things. As to the problem of limiting the access for the device, you should also be aware of some work that's happening kind of in anima, but doesn't really have a home, I think, at this point, which is Elliot Lear has been working on essentially, I believe it's called MUD, and it's a specification where manufacturer would say, essentially to your own firewall, your home firewall, expect this device to do this, this, and this. If it does anything else, there's a problem, right? And so this is a kind of thing that, again, the authorization server would pull down a especially magic URL that the device would provide with appropriate authorization and authentication, and would say, hey, okay, I see that you're a printer, and really, nobody should ever talk to you. So if I ever see you talking, it's a problem. But you can be on the network till then. So you may want to look at that work, because I think that may help you
that's a kind of,
help a
kind
lot
of
of your-
addresses the last bullet
Yes.
there. How do you?
Yeah,
because
so I
you
think
need to
that would help
specify-
you a lot for a lot of things. And so there's some other complementary work that I would love to interact with you to work on. Thanks.
Okay, thanks.
Thank you very much. So this is the end of the prepared talks for this agenda. We are a little bit ahead of schedule. There's one thing I would like to draw to people's attention. There is a document, I should have made a slide for that, I'm sorry. A document called Security Considerations, draft IETF T2TRG SecCons, that is nearly done, and it would be good to have a few more people look at that. The idea with this document is that other documents that might want to describe their security considerations can actually refer to this document, so they don't have to repeat all the common aspects that IoT security considerations usually share. And so it would be good to have a useful document out there, and it would be good to have a few more reviewers for this document. So those of you who occasionally write documents here, that might be a good document to look at, and also to see which parts of the document you want to cite in your next document, so you can save some writing. So other people in this room I have motivated enough to maybe want to do a review of the document? Michael wants to do one. Very good. I cannot see you against the window, but good. One more? Thank you. Okay, that completes our agenda. So unless you have any other business, we're done.
So if you haven't signed the blue sheet, please come here in the front and sign it now. And where is the other blue sheet? Okay, thanks.
I still have a set of comments from you on the ACE actors document that I still have to act on. So that's why I remember you. So if you want to look at the other document, that would be really great. Yes, thank you. We do. Thank you.
It's a pleasure to see you again. We met in Paris with Thomas 2 years ago.
Right.
It's a pleasure to see the evolution. I wanted to know, you are currently involved in several European research projects, and